Question number 8, a curve has equation y equals to 12 over 3 minus 2x, find dy over dx. So, we need the derivative. So, I am rewriting this equation as y equals to 12, this can be written as 3 minus 2x power negative 1. So, now we will differentiate dy over dx is going to be 12, then minus 1, 3 minus 2x minus 1, then derivative of this the inside of the bracket, that is negative 2. So, we have used the formula of derivative d power x n, derivative of x power n is n x n minus 1, right. So, now this is going to be, this is negative 12 times here negative 2, I am bringing it here. So, 3 minus 2x power minus 2. So, this is 24 over, this is 3 minus 2x power 2. So, this is our first derivative. This is the answer, right. Now, next question, a point moves along the curve. A point moves along the curve A. As the point passes through A, the coordinate is increasing at the rate of 0.15 units per second, and y coordinate is increasing at 0.4 units per second. So, this one here we are given x coordinate. So, dx over dt is 0.15 units per second. So, let me rewrite here dx over dt, this is equal to 0.15 unit per second, and then y coordinate, that is dy over dt, which is given us here, which is 0.4, right. So, these two things are given to us, right. Find the possible x coordinates of A. So, we are just looking for the x coordinate. So, now we will take here dy over dx. Now, dy over dx is going to be dy over dt times dt over dx. Okay. So, this dy over dt from here is 0.4, and dx over dt, we have dx over dt. So, we are looking for dt over dx. So, this is going to be reciprocal 0.15. So, you calculate this one, and I got it 8 over 3. So, dy over dx is 8 over 3. So, now if you see here, we have dy over dx from part 1, we have dy over dx is 24 over this 3 minus 2x. So, using part 1, we have dy over dx is equal to 24 over 3 minus 2x power 2, and this is equal to 8 over 3. So, now we will use this equation, cross multiply. So, we are going to have here 8 times 3 minus 2x power 2, when you multiply this one, and then we have 24 times equals to 24 times is 3. Okay. So, now divide by 8, both sides, this 8 and 8 is gone. So, we have 3 minus 2x power 2 equals to 8 times 3 is 24, 3 times 3 is 9. Okay. So, now from here we will have 3x, taking square root on both sides, we will have square root of plus minus square root of 9, that is 3 plus minus 3. 3 minus 2x, right. So, we have two options here, either we have 3 minus 2x equals to positive 3, or we have 3 minus 2x equals to minus 3. Okay. So, from here we have negative 2x, 3 minus 3, that is 0. So, it gives us x equals to 0. Okay. The other one we have here 3 plus 3, I am bringing this 3 here, and equals to 2x. So, this is 6 equals to 2x divide by 2 divide by 2. So, x is 3. So, we have the coordinate of x as 0 and x as 3. So, these are the x coordinates that we are asked, the possible x coordinates, right. Now, let us move to next question number 9. This question, the diagram shows a circle with center A and radius r. Okay. So, we have this circle here with center A here and diameter CAD. So, this is the diameter of CAD. If you look here, we have two circles, the big one and the smaller one. So, the diameter of the smaller circle is CAD, okay, and BAE are perpendicular to each other, they are at 90 degrees. Larger circle has center B, passes through C and D. So, this is the center of the larger one. Show that the radius of the larger circle is r square root 2. So, if this is r, this is also going to be r, right, this is the radius and this is the center of the smaller circle. So, we are looking for the radius. So, the radius of the larger circle is this one here. Let me denote this by capital R. Okay. So, radius of the capital circle is, so if you see, we have this triangle now. This is a right angle triangle CAB, okay, and this is R, and A to B, this is also R, because you see this is the center and this is the radius of the smaller circle. So, we can use Pythagoras theorem. By Pythagoras theorem, we will have capital R square, that is BC is going to be r squared plus r squared, which is equal to 2r squared. Okay. So, then r is square root of 2r squared. So, this is square root 2 r. So, this is the radius of the larger circle. Okay. So, we got the radius of the larger circle. Now, next find the area of the shaded region in terms of r. So, this question if you see is 6 marks. So, it is not going to be that easy. So, there might be some tricks. So, shaded area, you see this shaded area we have here. So, if we want to find out the shaded area, so area, let me write down here, shaded area is going to be equals to area of the smaller circle, this smaller circle, area of small circle minus area of the segment of the big circle, right. So, let me show you here, if I have area of the half of the area of smaller circle, because this is going to be half here, half the area of smaller circle. So, smaller circle area is this here, right, from here, and minus area of segment. So, this bigger circle is going to be have this segment here, this segment is like this one here, you see this red part. So, if you subtract this from here, the semicircle area of this smaller semicircle, the area of the segment, then we are going to get the area of the shaded part, right. So, let me rewrite this here, area of the shaded part, or we can say shaded area. Shaded area is half area of small circle minus area of segment of big circle, right. So, area of small circle, we will do it one by one. Let us say this is equation number 2, as we have done equation 1 in the first part. So, area of the smaller circle. So, smaller circle is this one here. So, its radius is r. So, half of the area of the smaller circle. So, we will write down here area of smaller circle, area of small circle is pi r squared, right. Half of this is going to be half of this. Let me see, write down pi by pi r cubed. So, let us say this is equation number 3, we are going to put this one. So, we got this one here, right. Now, we are looking for area of the segment of the big circle. So, for the area of the segment, this is part 1. The secondly, we need area of segment of big circle, right. So, this is going to be, now this is trick again. So, we are looking for this segment. So, this segment area of the this segment is going to be, we have to subtract this area of the triangle, area of this sector minus area of the triangle CAD. So, area of sector now we are talking about bigger, okay. I am not writing big and small as we have already written, we are talking about only big circle now. Area of sector minus area of triangle CBD, okay. So, area of sector is half capital R squared theta, and then triangle area is half times base times height, right. So, this is half R squared theta minus half. Now, let us see what is the base of this triangle. So, now if you look at this triangle, this one here, let me erase this one. Okay, so, if you see this one here, this is the triangle that I am going to shade now. This triangle is a right angle triangle. Why this is a right angle triangle? Because this is triangle in the semicircle. So, this is our smaller circle and this is the part triangle is here. Okay, so, as you can see that CAD is a diameter. So, this is going to be angle 90 degree, because this is angle in the semicircle, angle in, I mean the triangle, sorry, not angle, the triangle in semicircle is always right angle triangle. So, this is a triangle in semicircle. Okay, so, triangle in semicircle is always right angle triangle. So, that means that angle is okay, that angle is 90 degrees. Okay, so, we can substitute that angle here, and now we are looking for the base. So, as you see, this is the base, this is R, this is also R. So, this is right angle triangle. So, base times height. So, base is R, radius height is also R. So, I am writing here R times R, that is R squared, right. So, from here what do we have? We have now half R squared theta minus half R squared. Okay. So, now R we have from first part, R is small r square root r, this is square, and theta is pi by 2. As we are looking for the angle in radian, so I will write it pi by 2. So, then R is again R root 2 capital R and square, because from the from part A, right, from part A we have capital R is equal to R square root 2. Okay. So, now let us simplify. So, this is half times, when there is a square, R square times 2 times pi by 2 minus half R squared and times 2. This 2 and 2 is gone, this 2 and 2 is gone. So, we have pi R squared over 2 minus R squared, right. So, let us see, this was the area of the segment, and this from number 3 and 4, this is equation 4. So, now the area of the shaded part, right, area of shaded region this is from equation number this 2, that is in red, a half the area of the smaller circle. So, this area minus the one we got in equation 4, we are going to subtract that. So, that is half pi R squared minus half pi R squared minus R squared. So, this is half pi R squared minus half pi R squared when you expand the bracket. So, this and this is cancelled. So, area of shaded region is equal to R square. So, this is our final answer, right. I hope you guys understood. So, if you are getting benefit of these videos, kindly just take a minute to press the like button and share it with your friends. and write something in the feedback so that I can know how are these videos going for you guys, and any comment to improve further, right. So now let's say we have this question number 10. The circle is this, has center C and passes through points A and B. State the coordinates of C. So there are two ways, either you make it what do you call this, completed the square form, or you can just rewrite it into the compare with the expanded form of the circle, right. So this is 2y minus 20. So expanded form of the circle is x squared plus y square plus 2gf plus 2fy plus c equals to 0, where this is the formula actually I am telling you, where minus g and minus f is the center and the radius is equal to, we are not asked here radius, so I am just skipping, we are just looking for the coordinates of C, that is the center. So let me just skip this one. So we have here, if you compare with this, 2g is equal to 4, so g is equal to 2, right, and 2f is equal to minus 2 and f is negative 1, and the center is minus g minus f. So we are just going to change, minus g is minus 2, minus of f is positive 1. So this is the answer, negative 2 and 1. Now it's given that the midpoint D of AB has coordinates 1.5, 1.5. Find the equation of AB, giving your answer in the form of y equals to mx plus c. So consider, let me draw the diagram, rough diagram here, it will be easier. So this is your circle here, and let's say we have point A and B here, this is A and this is B, and we have a center here which is C, and the coordinate is negative 2 and 1. Okay. So if we drop down a perpendicular, then this is going to be 90 degrees, and coordinates of D is the midpoint. So D is this point, and we have the coordinates of D as 1.5. I am just writing here 1.5 and 1.5, right, leave it here. So 1.5. Find the equation of AB. We are looking for the equation of AB. Now CD is perpendicular to AB, right, CD is perpendicular to AB. So first of all we will see gradient of CD. What is gradient of CD? We will use y2 minus y1 over x2 minus x1. So CD is 1.5 minus 1 over 1.5 minus 2. So this is 0.5 over 3.5, this is equal to 5 over 35, that is 1 over 7. So this is gradient of CD. Now as CD is perpendicular to AB, so then we can find out gradient of AB. Gradient of AB is going to be negative 7. Why? Because we know when lines are perpendicular, product of their slopes is negative 1, right. So gradient of AB we got negative 7. So therefore equation of AB in y equals to mx plus c form. Y, m is negative 7, x plus c, right. So this passes through point 1.5 and 1.5. Okay, then we can take this, or you can also use equation of AB. It passes through point D. So it passes through point D, which is 1.5 and 1.5. So we can put these values. Y is 1.5, x is 1.5 plus c. This is 1.5 equals to 15 times 7 is 105. So it is 10.5. Wait a minute, 1.5 times 7, it is 10.5 x. Now x we have kept it here. So c. So from here c is equal to 1.5 plus 10.5. which is 12. So, we got value of C as 12. So, equation of the line is y equals to mx equals 7x plus 12. So, this is the answer from this equation. Okay. Now, let us move to the next one. Find by calculations x coordinates of A and B. So, by calculations, right. So, as we have the equation of the circle from part 1, x squared plus y squared plus 4x minus 2y minus 20 equals to 0, and we have y equals to negative 7x plus 12. So, now we will substitute this value of y over here to solve it. So, x squared plus y is now negative 7x plus 12 squared and plus 4 into negative 7x plus 12 sorry guys. So, minus 2 plus x squared plus y squared plus 4x remains as it is, minus 2 into y is again negative 7x plus 12 minus 20 equals to 0, right. So, now we will expand the bracket, x squared plus this is 49 x squared plus 144 a square plus b square minus 168x, then plus 4x remains as it is. Now, we expand this one which is positive 14x minus 24 minus 20 equals to 0, right. So, now we will combine the like terms. So, this is 50x squared, then x and x, we have these 3 terms here. So, it is 150 x plus 100, then these 44 100 1 to 44 minus 44 is 100 equals to 0. Now, this is all of these are multiples of 10. So, I can divide the whole equation by 10. So, it will be 5 squared minus 15x plus 10 equals to 0, right. Again it is divisible by 5. So, we can again divide by 5 to whole equation. Here we have divided by 10. So, x squared, it will actually simplify our equation, it will be easier to work. So, whenever you see equation can be divided by a common number, you can do that. So, now making factors, this is negative 2x minus x plus 2 is equal to 0. So, from here x is common, first 2 terms x minus 2, from here we can take negative 1 common, x minus 2 equals to 0, right. So, we have x minus 2 and x minus 1 equals to 0. So, this gives us x equals to 1 and 2. So, these are our x coordinates. That is what the question was, to find out the x coordinates of A and B. Okay. So, if they ask you point A and B, then you can substitute in this equation value of x, then we can get the value of y, and we will get points of coordinates, points of A and coordinates of A and B, right. Now, let us move to the next one. Number 11 is question from functions. The function f(x) is defined by this, where a and b are constants. It is given that a is this and b is negative 18. So, f(x) we have here x squared plus ax plus b. So, then we have f(x), a is 6, right. So, x squared it will become 6x plus b is negative 8. So, it will become negative 8. Okay. So, now the question is find the range. So, find the range. So, to find the range we have to make it in a completed square form, that is going to be easier. So, this is x squared plus 6s. To make that, half the coefficient of x subtract and add, right, and then we will see. So, this is now, this gives us x plus 3 squared minus this is 9 minus 8. So, this is x plus 3 squared minus 17. So, this is our f(x) now. Now, you see this is the minimum value of this is going to be 0. minimum value is going to be 0 when x is equal to negative 3, right, because it is a square term. So, it cannot be negative, right, minimum value is 0. So, the minimum value of f x minus 17, therefore, range of f x is greater than or equal to negative 70. Okay. Now, part B, it is given that it is given instead that a is equal to 5 and the roots of the equation f x equals to 0 are this and this. Roots means the values, okay, of x are k and negative 2, where k is a constant, find the value of b. So, f x is x squared plus a x plus b. Now, a is 5, that is what we are given here, a is 5. So, then f x becomes x squared plus 5 x plus b, right. Now, and f x is 0 and f x is 0. So, this means this is equal to 0. So, that means let me rewrite x squared plus 5 x plus b is equal to 0, right. Now, we are given that now because k and negative 2 k are the roots of this equation. So, therefore, that means x minus k and x plus 2 k are the factors of this, are the factors of f x, are factors of f x, right. So, then we can write it here like, therefore, x squared plus 5 x plus b will be equals to x minus k and x plus 2 k, right. So, now we can expand right hand side and then we can compare these equations. Okay. So, let us again write left hand side as it is, because we are not going to do here. Now, expand this x times this is x squared plus 2 k x minus k x minus 2 k squared, right. So, x squared, do not touch this left hand side, it will remain as it is. So, x squared, these are two like term, 2 k minus k is k plus k x minus 2 k square. Now, equating the coefficients, we have, you see x squared coefficient is 1. So, then this and this coefficient of x is k here, on the other side it is 5, right. So, we got k as 5 from here and the constant term is here negative 2, k is equal to b, right, 2 k square, sorry, here was k square. So, 2 k square is equal to b. So, negative 2, k is 5 equals to b. So, 5 times 5 is 20, 25 times 2 is 50. So, this is negative 50. So, b is negative 50. Okay. Now, next one, show if the equation f x plus a has equals to a has no real roots. Now, no real roots, then a squared is less than this condition. So, f x plus a is equal to a. First of all, we will see. So, f x was, let me write down here, f x is x squared plus a x plus b. Okay. Now, we are looking for f x plus a. F x plus a, we are going to replace this value x by x plus a squared plus a into x plus a plus b equals to a, right. That is what we are given. So, expand the bracket, x squared plus 2 a x plus a squared plus a x plus a squared plus b minus a equals to 0. Combining the like terms, x squared plus this and this 2 a x plus 1 a x is 3 a x, then a square plus a square, this and this is 2 a squared plus b minus a, right. So, this is our constant term which is independent of x. Okay. So, this is now quadratic in x. You see x squared, x, and then the constant term we have here with this is a quadratic with a equals to 1, b equals to 3a, and c is equal to 2a squared plus b minus a. Now, we are given that this equation has no real roots. So, for no real roots, b squared minus 4ac is less than 0, right. Discriminant should be less than 0. So, then b is 3a squared minus 4, a is 1, and c is 2a squared plus b minus a is less than 0. Okay. So, this is 9a squared minus we have 4 into 2a squared plus b minus a is less than 0. Okay. So, now I am shifting this looking at these equations, you see we have to reach here. So, a square is on the left hand side. So, a square I can see here, a square is here. So, I can do 9a squared is less than, shift everything on left hand side, right hand side, 2a squared plus b minus a, right. So, now when you expand this is 9a square less than 4 times 2 8a square plus 4b minus 4a by expanding the bracket. So, shift this 9a squared minus 8a squared less than 4 is common from here is b minus a. Okay. 9a minus 8a is a square is 4 into b minus a. I think that is what we need to prove. Yeah. Yes. So, this is what we need to prove. So, we can say hence we have proved that. Okay. Now, let us move to the next one. I think this is the last question of this paper. Yes, this is the last one. So, this paper was long actually, usually nowadays you get 10 to 11 questions. So, this was the paper from 2020 and it has 12 questions. Okay. So, the question that we have a curve here, the diagram shows the curve with y equals to this and the minimum point at the curve has coordinates this, and the maximum point is at b where a and b is constant. So, you can see this point is maximum point and this point is minimum point, right. Okay. So, we have let us see, state the value of a. So, at x axis, as you can see point A is on x axis, at x axis y is 0, right. So, we can substitute that one here from the equation, that equation is x minus x into x minus 2 square is equal to 0. So, it gives us two values, either x is 0 or x minus 2 squared is 0. So, from here x is equal to 2. So, as you can see this is the value of x here. So, that means a is equal to 2. So, a is 2. Okay. Now, calculate the value of b. So, now if you see b is a point at point b, it is a maximum, right. So, it has a coordinate of, this coordinate is b and something. Now, for maximum value of x, so for maximum, now what we can write down, now we have maximum at, we have maximum point at x equals to b. Okay. So, y is equal to x into x minus 2 squared equals to x into x squared minus 4x plus 4, right, just expanding the bracket. So, then y is equal to, expand it again, x cubed minus 4x squared plus 4x. Now, we can differentiate dy over dx, it is 3x squared minus 8x plus 4, right. So, at maximum point dy d should be 0, at maximum point dy over dx is equal to 0. So, that means 3x squared minus 8x plus 4 is equal to 0, right. So, now we can make the factors 3x squared minus 6x and 2x plus 4 is equal to 0. So, 3x is common. So, it is x minus 6 minus 2 is x minus 2 equals to 0. So, this is when we take out x, I mean this 3 common, here we will have only 2 left inside from here. Okay. So, then we have x minus 2 into 3x minus 2 is equal to 0. Okay. So, then x is equal to 2 and 3x minus 2 is 0. So, x is equal to 2 over 3. So, x equals to 2, that we already have here, we have taken a as 2. So, this is a as 2. So, the other point is going to be b, which is 2 over 3. So, value of, that means value of b is 2 over 3, right. Now, part C, find the area of the shaded region. If you see, this is the shaded region. So, shaded region we are just going to do integration, but we need to know the limit. So, limit is from here to here, as the value of a is 2. So, limit is going to be from 0 to 2. Okay. So, we will just integrate. So, shaded area integration of the curve from 0 to 2. X cubed minus 4x squared plus 4x into dx, right. So, this is going to be x 4 over 4 minus 4x cubed over 3, limits are from 0 to 2. Now, we will just substitute the limits. So, first we are going to put 2 power 4 over 4 minus 4 into 2 power 3 over 3 plus this became 2 into 2 power this, and then when we put minus, as you can see 0, this is 0, this is 0, all of them are 0. So, there is no use of that. So, this comes out to 2 times 2 4, 4 times 4 is 16 over 4 minus 4 into 8 over 3 plus 2 times 4 times 2 8. Okay. So, this is 4 minus 32 over 3 plus 8, which is 8 plus 12 minus 32 over 3, taking LCM. So, this is 3, 12 times 36 minus 32, which is 4 over 3. Area of shaded region is 4 over 3 square units, right. Finally, we have this part D, which is the last one here. The gradient dy dx of the curve has minimum value m. Calculate the value of m. Now, dy dx from the previous part we have 3x squared minus 8x plus 4. Now, then for minimum point we can calculate this second derivative, which is 6x minus 8. This will be equals to 0 at that particular point, right. So, then x is going to be 8 over 6, that is 4 times 2 times 4 and 2 times 3. So, we got x is equal to 4 over 3, right. So, x coordinate at minimum point is 4 over 3. So, therefore, we are looking for the value of m. A value of m is derivative, first derivative at x equals to 4 over 3. So, first derivative we already had here from here. So, 3x squared, x is now 4 over 3 squared minus 8 into 4 over 3 plus 4. Now, we will just simplify it. So, this is going to be 3 into 16 over 9, 32 over 3 plus 4. So, 3 times 3, 16 over 3 minus 32 over 3 plus 4. So, taking LCM, we have here 16 minus 32 plus 4. 16 plus 4 is no, it is going to be 12 here when we, because there is nothing here down 4. So 16, this is 28, we have 16 minus 16 over 3 minus 32 over 3 plus 4, right. So let me do 16 minus 32 plus 12. So 16 plus 12, it is 28, minus 32 over 3, it is negative 4 over 3. So that means our value of m is minus negative 4 over 3. So that's it, guys. All the best for your upcoming exams. Thank you so much for watching. Kindly subscribe and share it with your friends. Please write in the comment section about the feedback, and let me know when is your maths exam in exam series. Thank you so much. Be blessed, guys.